Today, we're going to be talking about alveolar gas equation. So I'm going to be sharing with us how I remember alveolar gas equation without memorizing it. Very easy and simple. So looking at my diagram on the left side, so this is going to represent our, to call this airway, going to be the alveolar, and of course, outside it's going to be our atmosphere, right? As you all know, gas move based on pressure gradient. So we move from the point of high concentration to the point of low concentration. And Alveolar gas equation is an equation that we use to indirectly estimate the amount of the partial pressure of oxygen inside the alveolar. So our P capital AO2 would be an indirect estimation of partial pressure of oxygen in the alveolar. And there are a couple of parameters that influence or that help us to determine this partial pressure of oxygen in the alveolar. The first one is going to be the atmospheric pressure, which some people refer to as barometric pressure. Second one will be our PiO2, which is the partial pressure of oxygen in the inspired air. Number 3 will be our FiO2, which is a fraction of inspired oxygen. Number 4 will be the PHO2, which is the partial pressure of water or water vapor pressure, because we need water to be able to humidify the oxygen in the airway. And number 5 is going to be our PaCO2, which is the partial pressure of carbon dioxide. And number 6 will be the respiratory quotient. And the respiratory quotient is the volume of carbon dioxide released over the volume of oxygen absorbed during respiration. And of course, usually use 0.8. So coming back to our diagram, like I mentioned earlier, right? Gas move based on pressure gradient. So from high concentration to low concentration, right? Where there's more pressure to where there's low pressure. So this atmospheric pressure, which is our P, atmospheric pressure, right, is going to determine the gas, right, that gets into the airway, right? So that will influence what gets into the airway. And to further calculate the oxygen in the inspired air, that would be our PiO2, right? So like I mentioned earlier, right, when the gas gets into the airway, it needs to be humidified. So humidification will occur, and that humidification will further decrease the concentration of oxygen in the inspired air. So that means the partial pressure of oxygen in the inspired gas will be our P atmospheric pressure, right? And then we have to subtract the partial pressure of water from it, which is PHO, right? And out of all these gas, right, we have to multiply by our FiO2, right? And the FiO2 is the fraction of the inspired oxygen, because it's not all the whole gas that is oxygen, right? Just 21% of it is oxygen. So we have to multiply by our FiO2. And normally, the FiO2 is usually 21%, and it can vary, especially if patient is on oxygen, right? Because for every 1 liter of oxygen that you put the patient on, right, that will increase your FiO2 by approximately 3%, right? So that means if I put my patient on 2 liters of oxygen, right, so that means the FiO2 will increase by 6%, right? So then I'm going to add this 6% to the 21%, right? And that will give me 27%. So a patient that is on 2 liters of oxygen, that means their FiO2 will be like around 27%, right? So this is going to be our partial pressure of oxygen in the inspired air, right? And then lastly, when we get into by the time the gas gets into the alveolar, we have to remember that the last gas during expiration, right? Expiration is when you breathe out, right? So the last gas during expiration is usually carbon dioxide, right? And so that means by the time the gas gets into the alveolar, because the last gas there was carbon dioxide, that will further decrease the oxygen that gets to the alveolar, right? And hence the alveolar gas equation. So if you want to calculate the alveolar gas equation, so that means we have to subtract the partial pressure of carbon dioxide from this partial pressure of oxygen in the inspired air. So that will give us PiO2, right, minus the partial pressure of carbon dioxide, right, divided by the respiratory quotient. And this is going to be basically our alveolar gas equation, right? So in summary, right? So atmospheric pressure comes into the airway, right? Being humidified, right? So humidification, that will further decrease the partial pressure of oxygen in the inspired air. So that means we have to remove the partial pressure of water from the atmospheric pressure, right? And we're going to multiply by our FiO2, right? Because everything is not oxygen, just 21% of it is oxygen, right? And that will give us the partial pressure of oxygen in the inspired gas, right? And then from there, it's going to go into the alveolar, right? And then remembering that the last gas in the alveolar is carbon dioxide, so we need to subtract the partial pressure of carbon dioxide from the inspired gas, right, to be able to get the true oxygen then to be in the alveolar, right? And so if we want to expatiate our formula, so we can say our P capital AO2, which is the partial pressure of oxygen in the alveolar, will be equal to P atmospheric pressure, right, or barometric pressure minus the water vapor pressure, right, in brackets, multiplied by our FiO2 minus PaCO2 divided by respiratory quotient, right? So this is basically our alveolar gas equation. And I so much love this equation because looking at this equation, I can come up with different things that can influence different differential diagnosis that could influence the amount of oxygen that get to the alveolar, right? So if somebody have any condition whereby they are retaining a lot of carbon dioxide, like in a patient who have COPD, patient with hypoventilating, right? Or patient who have any form of hypercapnic respiratory failure, right? So because of the increase in the partial pressure of carbon dioxide, that could further decrease the amount of oxygen that gets into the alveolar. Same thing if anything decrease the FiO2, right? Maybe because somebody that was on oxygen, the oxygen finished, or there's a kink in the tubing connection of the oxygen, that could decrease the amount of FiO2 they're supposed to be getting, and that could also decrease the amount of oxygen in the alveolar. Likewise, if there's a decrease in the atmospheric pressure, like for instance, if somebody go to high altitude, because as you go to high altitude, the atmospheric pressure decreases, right? That will also decrease the amount of oxygen that gets to the alveolar. And that's why we are so much concerned when we have our patient that have some underlying unstable respiratory diseases, right? We are so concerned about them flying because we know that that flying could impact the amount of oxygen that gets to their alveoli. And I hope this help you guys to remember alveolar gas equation, just the same way I remember it without memorizing it.